Next step in order to develop the framework for the perturbation theory is to take two arbitrary gauges, gauge 1 and gauge 2, and let us use this notation. For gauge 1, we will define their coordinates using x alpha caret. For perturbed gauge 2, we will define their coordinates using x alpha tilde, and for the background universe, we will have x alpha. So there are three coordinate systems: the background universe, perturbed gauge 1 and perturbed gauge 2. And we have seen earlier that in the perturbed universe, there are many perturbed gauges. One of our goals is to transform the value of perturbation quantities from one gauge to another gauge. So we want to transform from one gauge to another gauge, and in order to develop the framework, we are taking two arbitrary perturbed gauges, and then we will develop the equations for transforming the value of perturbed fields from one gauge to another gauge. Next, let us define an important object called the transformation vector. So the transformation vector gives us the relationship between the coordinates of gauge 1 and gauge 2. So x alpha tilde at an arbitrary point P is equal to x alpha caret at the arbitrary point P plus xi alpha at P. Xi alpha is the transformation vector. So this is how the coordinates of two perturbed gauges are related at an arbitrary point P. So the important thing to note here is that we are taking one fixed point P in the four-dimensional space-time. So at that fixed point P in the four-dimensional space-time, this is how the coordinates will be related, and xi alpha is four-dimensional vector. And xi alpha is very, very small. So the gauges, the variation between the coordinates of gauges is very, very small. So we will keep the terms, we will keep xi alpha only up to the linear order. And the if there are terms of second order or greater than the linear order, then we will drop those terms. Xi alpha being small, we'll keep it only up to linear order.